Okay, my friends, I think you know electron flood theory says that there is nothing but electrons and that the positive portion of the electron, because it's a dipole, the positive portion has no charge other than a carrier charge. The negative portion of that dipole is extremely explosive. So you have an extremely energetic side and you have an extremely dead side. And when they interact and slam together, the red parts, which I'm showing, normally they would be white, they explode. And the black parts just roll away and get out of the way. Now, this is a nuclear core, and these are the electrons that try to get in. As they get bigger and bigger and bigger, they get more and more surrounding to try to get in, because the positiveness will say, okay, you guys come on in, but the negativeness say, we're surrounding that positiveness, so you guys have to stay out at a certain distance away. It's called quantum. Now, this I am going to show in extreme detail everything I'm talking about, because this is a wave. That they consider it a wave, but it's really a particle, and that is the particle. The wave is the sphere of influence that particle controls. That's what magnetism is. That I really can't get to a solution for, but I do know those two particles control a sphere of magnetism which is enormous. It's called the 21 centimeter rule. Now, as it goes flying through the air like this, we sent it through a venturi. Rod Warren developed this venturi, and it makes the particle accelerate. So we can see it's a particle, we can see it's accelerating, we can see that it is now turning white because, as I said, there's a portion of that particle that is extremely explosive, and that's the white part. The black part walks away, and I can see them actually walking away here, and you will too in a minute. But here's what I want you to see now. The concussiveness of these white particles against the other white particles, crushing each other into this venturi here, and they're forcing each other to crush into each other's regions, and they explode like a bomb. You see this? Why is that white on this? Why is that white? Why is this white? Why is this completely white? Why are all these tiny little particles white? Why are we seeing this line back here, this huge line? You see that big, huge line back here? You see these little white particles? What is all that about? I could tell you what it's about. When this is shooting forward, it's sending that particle in an extreme speed, exploding here like a bomb, creating this wave. Boom, 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 boom. That's all ripples of the force back, and it's forcing back against these that are coming, making them turn extremely brilliant. Because there's fields everywhere here, but you don't see them until they are in such extreme concussion that they illuminate themselves, and these are extremely concussed. Now, there's things that are to come out of this research that are absolutely phenomenal. Let's take a little deeper look. But don't forget now, this is the wave, but it's actually a particle. And I'm going to show you how all of the other particles that are in the air are free-floating electrons. We'd call them ether. They used to call it ether. And it's not only is it free-floating in our air, they're extra electrons, and they collect on you as static, and they discharge to ground when the air is dry, because there's extra electrons in the air, and they're normally just floating around all the time. However, when it's dry, they have nothing really good to attach to, so they'll find you, and then you'll make them go to ground. 100% of everything there is made of dipole electrons. One positive, extremely explosive part, negative, extremely explosive, and one positive, just actually dead, doesn't do anything. So the excess electrons creates heat. Anything that has excess electrons in matter is warm, and it's heat. If it doesn't have enough electrons in it, as everybody else around it does, it's cold, and it will want some. And so it's always in relation to its surroundings. Right? So if something is 50 degrees and everything else is 100 degrees, well, it wants to warm up to 100 degrees. And if it's 100 degrees and everything else is 50 degrees, all the other 50-degree guys are going to say, give me some of that 100-degree. It's as simple as that. And they're electrons. They go in, they go out. They walk in, they walk out. That's called electromagnetic radiance. And there's a certain amount of it called a Kelvin. And at 0 kelvins, you have absolute zero. And I find that kind of tee-hee funny, because 0 electrons, if there's 0 extra electrons in the mass, it's locked solid. Nobody can do anything. And that's absolute zero. And that's absolute zero will suck every electron you can give it. That's why they say it flows continuously, obviously, because it wants electrons in there. Everything wants to have electrons. But it wants them up to a certain point, and then it's what's called the ultraviolet catastrophe. Because they will accept electrons until there's so many electrons in it, you can't take them anymore. And there's going to be a temperature, it's called 58, I think it's 5800 Kelvin. You won't take them anymore. It's too much. And then that's the catastrophe, and that's not supposed to happen according to physics. So that's called the ultraviolet catastrophe. We're going to look into it, and everything relates to the electron that is in the air, and just floating in the air, just attached to extra water molecules primarily. Water loves extra electrons, loves them. So when the air is moist, it's got all kinds of extra electrons, everybody's happy. That's in the ether of the air. Now, when it gets dry in the air, there's not enough water molecules, the static, there's those extra electrons say, well, where am I going to go now? And they say, well, I don't know, there's a guy walking over there, he's got a lot of water in him, jump on him. And that's what happens, the static collects to you. And you rub on the rug, it's just laying all over the rugs looking for a place to go, and it gets on you, and then sooner or later, because that's off the ground, it's not attached to ground. After it gets on you, and you touch a water pipe or something, that's when it snaps to ground, because the ground is nothing more than an electrical generator that's sucking electrons through itself. And that all happens because of the interaction with the atmosphere. It's all fully understood with electron flood theory. Nothing is not understood now, because you had to understand that this is the nature of the nucleus and the molecule. And, you know, it goes a lot deeper than this. It goes way deeper than this. All right, and we're going to get there, but it's going to take a little while. So if you want, stay with me. But ether saturates the universe. They knew this. Plato talked about it. They all talked about it. And now all of a sudden you came up with Einstein, these guys. Oh, there's nothing out there. It's all just a vacuum, total nothing. And so, well, how does the sunlight get to us? Well, there's nothing there. It's just a wave or a flappy something. No, obviously not. It's a particle, and it's these particles right here. They come through this vacuum of space, which is not a vacuum, it's saturated with these particles. And as we scrub our planet through it, it creates magnetic rub against them, because we're scrubbing the same particles against those. They're pushing back against us. It's just a generator. And the same thing with the sun. That's why the corona is millions of degrees at the scrub zone, and the surface is 6,000. There's no other reason for that. And the same thing on the Earth. It's 80, 90 degrees on the surface. It's thousands of degrees in the magnetosphere. That's how it works. The universe is 100% saturated with these little particles. And I'm going to show you them right now, because not only are they those particles, when you see them in a non-excited form, you see this? This one here has not been excited. We're not approaching a Venturi. That's just the beginning of the wave. What happened? What's all this? What's all these little particles out here? Those are electrons. Those are, again, they're all the particles that are floating around that are excess. All right, as this concusses out, they start glowing. I can't account for why when they concuss with each other they glow, but I can damn sure show it. And I can show the actual positive portion, the carrier portion of the electron walking away from the explosive portion of the electron. I'll show you that right now. Now here's what happens as they come out of the venturi. They come out really just crazy fast, and then they start to slow down, and you can see them as to what they are, and they are back-to-back dipoles. Okay, this is just a real exceptional shot of a green one, because we have them green and red, and I'm not sure he has any in blue, but we have them for sure in green and red. Now, I'm showing this as like back-to-back electrons. This is a positive and a negative, positive and negative, and here and here. So they attach this way, they attach this way, they attach this way, they attach this way. But not only that, in a box, they would attach in this. So it's like a four-banger. All right, there's 1, 2, 3, and 4, and they've attached together as a compressed photon. All right. Now, as these things move through the air, these are little polar spots. So the positive is going to hit with a negative, and a positive, negative, that type of thing, and they're going to spin like crazy through the air. That's what these do. They spin. There's no question they spin. And now, so we saw it coming out in the trail, spinning in the trail, and then sort of locking down for a second so that we could see it. Now, let's look at what happens. Okay, my friends. Now, as you know, electron flood theory is the new model of the atomic nucleus, which is nothing but electrons. There's not big, gigantic protons and neutrons, and then two tiny little particles floating around out there for helium. There are thousands of electrons in the core, and then two electrons trying to get into the core, which says, no, we have enough negativeness in here, you have to stay out there. That's how molecules are made. It's called electron flood theory, and I have to explain every single thing there is, and one of them is black body radiation and absorption. All right, and we're going to go into that right now because it leads to the ultraviolet catastrophe, which nobody can explain without electron flood theory. Plus, nobody can explain anything without electron flood theory. The excuses that have been made in physics is absolutely unbelievable. And we are going to go to right here, the Rayleigh-Jeans law, which is about electromagnetic radiation, which is nothing more than electrons flowing in and out of materials. And everything is dependent upon temperature. Everything 100% is dependent upon temperature. Why? Why is 100% dependent upon temperature? What is temperature? They don't even know. They just think, well, it's hotter or it's colder. Well, it's all it is it's temperature means it has too many electrons when it's hot and they want to flow out. And when it's too cold, they want electrons and they pull them in. And then you end up with the same temperature as everybody else in that same given area. It's called ambient temperature, and then you have no flow of electrons in or out. Simple as that. That's what temperature is. Now, we're going to go in deep now. Hello, my friends. I'm going to explain something to you today. This is Roger once again. Now, do you ever hear the word constant? In regards to physics, Boltzmann's constant, Planck's constant, the constant speed of light, the constant this and that. Well, they're based in nothing other than the fact that this is what they see and this is what they can determine by examination, and they have no clue why. So they make it into a constant. All right, and Boltzmann's constant is the proportionality factor relates to average kinetic energy of particles in a gas in a thermodynamic temperature. But it's always temperature, it's always temperature, it's always temperature. It occurs in definition of the Kelvin, which is the temperature of one particle, and the gas constant, which is a constant of the pressurization of the gas, basically. And in Planck's law, which is Planck's constant of black body radiation, they don't know why that happens. They don't know how and why the ultraviolet catastrophe happens. And my theory of electron flood covers every bit of this, 100%. Now, Boltzmann's entropy formula changes the way the mass of the body is, actually. So the Boltzmann constant has the dimension energy, how big the size of the quantity of particles divided by the temperature, the same as entropy. It's named after this Ludwig Boltzmann. Now, all of this stuff relates. If you come back to the Kelvin, Kelvin is the base unit temperature in the unit symbol K, and what it is, it's really how much energy it takes to change, I'm going to say 1 electron up 1 Kelvin degree. It's not that, but it's, just think of it that way, because we're taking electrons and we're saying if you're an electron and you're not being pushed on, you don't have any energy. You just don't have anything. You're just laying there doing nothing. But as somebody starts to push on you, you're going to start to grow your temperature and your energy and your kelvins. And that's what we're going to measure. Now, consequently, if you have a mass that has 0 extra electrons, no extra electrons in it whatsoever, and everything has extra electrons if there's any temperature in it whatsoever. However, if you have absolute 0, and seriously, that means absolute 0 extra electrons, you have a mass that's locked in. There's no extra electrons to move around, because you can send electricity through anything if you have enough push to it. It's just the extra electrons move. Now, when it gets cold, well, this is going to be too thin. All right, the reason I just stopped in the middle of that was because I was talking about a substance. It's called absolute 0. That means there's no extra electrons in it whatsoever. And normally there's a lot of extra electrons. Now, where there's a lot of them is in this row right here. Copper, silver, gold, and then you got nickel, palladium, and all this zinc right in this cadmium. All of this stuff here is, it can push electrons this way or that way. That's all it is. This is, well, we're going to go into this very, very, very deeply, because this I love, is the transition metals. These are the metals of life. And this is why you see all these different crystals and these different colors. And I get into it quite deeply. But this is where we're going to be going. Now, the reason I went off of that last subject about the absolute 0, because there's absolutely 0 electrons that are extra. As soon as you put a little bit of electricity into it, it starts to heat up and oppose that. So it becomes more and more resistive to the flow of electricity. But at first, they just shoot through there like, and if you kept it that cold, they'd go forever, because there is no resistance. There's no electrons in there. They want to go through there, but you have to keep it at that temperature. That means you got to pull all those electrons out somewhere. Now, I'm going to show just really quick, because I was kind of impressed with a couple of her first statements, and then I'll leave it at that for today. Okay, I'm going to leave the last statements here, and then I will be doing extensive chemistry on a lot of things, but this is going to be one of my fun parts.
Okay, so Transition metals, d block metals, because they have those d orbitals. Yes, we're going back to talking about orbitals again. And they're called transition metals because you transition from this part of the periodic table with your what kind of orbitals? S, to this part of your periodic table with your what kind of orbitals? P. So they are the transition metals. And they're often really reactive and very cool. And many of them, since we're on a biological theme, many of them are super important in biology. And I have some of these written down in your notes, but here they are. Up here in the transition metals, you have a lot of metals that we could not live without. Iron carries oxygen to...
All right, she's extremely good, as far as I can tell. I haven't gone real deep, but she's going to be towing the company line about the way the nucleus is built. And it doesn't work. Once you take the nucleus and you say that it's all electrons, and I have shown, well, I'm going to show it to you right now to just prove my point, and then I'm going to leave it at that for today, because this is going to get very complex, but it's going to be also very easy. All right, this is just a very quick, simple illustration of what molecules and actually the nucleuses are made of. And they are exactly what Nikola Tesla said. If you want to find the secrets of the universe, think in terms of energy. All right? And that is in frequency and vibration. You know, this looks like things in terms of all three of those things. Well, energy is the product of frequency and vibration. Now, I'm going to let this play, and I'm going to just try to explain what is going on. And it was Nikola Tesla, the smartest guy on the face of the planet. Now, you have NaCl on both sides of the periodic chart, so a heavy minus and a heavy plus. That makes a polar molecule. They are going to send a frequency in, which is just an oscillation of electrical charges, really. Now, what happens is it's going to vibrate that metal plate using the tone generator. As the pitch increases, it becomes more and more complex. Now, we're going to start out way low at 345 hertz. Now, what that means is a very long frequency wave like this. Very long. Now, that's hydrogen. Hydrogen has only this s orbital down here. Remember they talked about s orbitals and p orbitals, and these are the d block. Well, this is the only thing you can have in this s one here is hydrogen, helium. And then you can have one here, one here, one here, or one here. One of those is a hydrogen. Or you can have two, either there or there, is a helium. All right, so that's as much as complex as you can get on the very lowest period of the chart. Now, as you start getting more and more complex, you go into the rule of 8. But what you want to understand is all of those little particles that are buzzing all over, those are electrons. Those are literally electrons in the world that I'm in. Now, there's so many of them, they just buzz until they are pushing their neighbors into their resonance stable zones. And we're in the rule of 8 now. And it always has the core, and outside of it, it pushes everything out. Now, I've shown this so many times. I'm just going to go up to where it gets real complicated. The higher you go up in the frequency, which means more and more pressure, it gets more and more complicated, and I mean complicated. And that is what is in the center of the nucleus. It's not in the center of a nucleus a whole bunch of positives and a few neutrals. No, absolutely not. They are all electrons, and the electrons are part of this little, these aren't like one big electron here. There's a bazillion little particles that make those walls of these zones. All right, because that's what they do. They're building their own little walls. See? They're creating their own little walls of these zones. And at an exact frequency, they lock in. However, you can add a few particles here, take a few away there. Those are called isotopes. We're going to get into this deep, but I think I'm going to like this this woman here. We'll find out. All right, I'm going to leave it at that for today. Thank you. Love you all. All right. Bye-bye.